Good morning, class. Today we will be discussing the ear, specifically the vestibular apparatus. That's the system that's going to be in charge of keeping the body's equilibrium balanced. So before we can dive into the vestibular apparatus, we're going to talk about um, the parts of the ear. So we have our external, middle, and inner ear. So the external and middle ear transmit sound waves to the inner ear. In the inner ear, there's going to be hair cell receptors that transform sound waves into electrical impulses. Those impulses are going to allow an organism to hear. The ear also plays a role in equilibrium. So in the inner ear, there's a component called the vestibular apparatus. This sensory system is going to sense orientation and motion. So orientation and motion is your equilibrium. So if you look here at this picture, we have our outer ear, external, we have our middle ear, and our inner ear. Our vestibular apparatus is this area right around here. So the vestibular apparatus is located in the inner ear. So this component of the ear is going to detect changes in position and motion of the head. It consists of two structures. So we have the semicircular canals and the otolith organs. So to the right, we have a picture of the vestibular system. We have our semicircular canals. If you look at my mouse, there's 3 canals, 1, 2, and 3. And then the otolith organs. So the otolith organs consist of the utrosul and the saccule. So these 2 organs right here. The semicircular canals, they consist of 3 canals. So we have the anterior canal, the posterior canal, and the horizontal canal. So the first picture shows you the position of 3 canals. You have your anterior canal here on the top, your posterior is on the bottom, and your horizontal one is more flat. So these canals are filled with endolymph. Endolymph is a liquid substance. As the head moves, the endolymph fills the canals. Well, the endolymph fills the canals, and as the head moves, the endolymph is going to move with the head. So the endolymph is going to flow into an area of the canal called the ampulla. In the ampulla, there's going to be receptor hair cells, and they're covered by a jelly-like substance called the cupula. So when that endolymph flows over the cupula, these hair cells detect the rotation of the head. So that includes acceleration and deceleration. So for example, nodding up and down, shaking your head, or tilting your head. So this image, you have so here's the big picture right here. You have your semicircular canals, and it's focusing in on the ampulla. So this right here is the ampulla. Whenever the head is in a still position, your cupula is standing straight up. You see your hair cells here. So the endolymph it's not moving. It's just sitting in the semicircular canals. As the head rotates, that endolymph is going to pass over the cupula and it's going to bend it. And that bending is going to alert the nerve cells, and that's going to send a signal, which in turn is going to tell your body that the head is rotating. So the second part of the vestibular system are the otolith organs. So the otolith organs consist of the utricle and the saccule. These structures are located between the semicircular canals and the cochlea. Sorry. So we have our semicircular canals here. So you have your anterior canal, your posterior, and your horizontal, and you have your cochlea right here. So in between the two are the utricle and the saccule. So these are the otolith organs. So together, they give the body the position of the head relative to gravity. So like the tilt of the head and the linear motion of the head. So moving in a straight line regardless of direction. The utricle is going to detect horizontal movement and the saccule detects vertical movement. Like the semicircular canals, the utricle and the saccule have hair cells that detect the motion of the head. So if those hair cells are stimulated, then they convert the stimulus into an electrical impulse, which is going to tell the brain that the head is moving. So those hair cells are in both the semicircular canals and these otolith organs. So the hair cells that line the vestibular system are mechanotransducing sensory cells. So this means that they can convert a mechanical stimulus into an electrical signal. Earlier, we mentioned that endolymph is moving through the vestibular system. So in the hair cells case, the movement of endolymph is what activates them to change that stimulus into the electrical signal. So each bundle of hair cells consists of one cilium, the kinocilium, and about 20 to 50 microvilli. So these microvilli actually give the hair cells their name because they look like little hairs growing inside of the ear. Whenever these hair cells are lost, it can lead to complications like dizziness and loss of balance. Since the vestibular system functions to process sensory information that's in charge of balance, this system is essential to everyday life. So without it, you wouldn't be able to do the functions that you do in your everyday life. If there are complications within the vestibular apparatus, it can lead to disorders and illnesses. Of course, when you make a sudden movement and the vestibular system becomes unbalanced, you can feel symptoms like vertigo. Many people actually think vertigo is a disease or a condition, but it's really just a symptom. Um, I've never had vertigo, but people say it feels like the world is spinning. And I've actually seen my mom suffer from vertigo a few times, and it doesn't look fun at all. Um, you feel like the world is spinning. You feel unbalanced, so it's definitely not a good feeling. Um, Diseases like Meniere's disease can also occur. So, Meniere's disease occurs when there's too much endolymph in the vestibular system. So, remember, we said that endolymph is that liquid that's flowing between the semicircular canals and the otolith organs. This disease usually occurs in people between the ages of 40 to 60. So, probably about um, mid adult, and there's actually no cure. So people fighting with Meniere's disease experience being unbalanced, dizziness, hearing loss, and headaches. They actually say that to treat Meniere's disease, people can eat low sodium diets and, of course, take drugs that will reduce the feelings of unbalanced and vertigo. All right, so we have covered all the basics of the vestibular system, from structures to complications. So let's do a short summary. First, the vestibular apparatus is going to function to control your balance and equilibrium. So it's made up of two main structures, the semicircular canals and the otolith organs. So we'll look at this picture. We have our three canals here, our posterior, our anterior, and our horizontal. And we have our otolith organs. Endolymph is going to circulate between those two structures, and it's going to stimulate hair cells whenever the head moves. So once those hair cells are stimulated, they're going to send an electrical impulse to the brain. So it's going to pass through the vestibular nerve to the brain. And that's going to tell your brain, okay, the head's tilting, the head is shaking. It's going to keep you balanced. So that's all on the vestibular system today.